Hey everybody, I'm going to do a quick video on Electro-Culture history. This book here is by Justin Christofleau. We're not going to get through it all, but we'll get through part of it. I'll read a couple of the first few pages and we'll take it from there. So, Electro-Culture by Justin Christofleau, member of the Society of Scientists and Inventors of France. And this is Justin Christofleau himself, and as you can see, his credentials kind of speak for themselves. All right, and we're going to get on to the meat and potatoes of it. This here's just the introduction, signed by Justin Christofleau. Skip through that, and here's the meat and potatoes. This is the apparatus that is being shown for the page I'm about to read. Electroculture is a method of applying atmospheric electricity to the fertilization of plant life, and has, during the past few years, developed to such an extent that it is today being practiced in many of the countries of the world. For example, France, England, Canada, Germany, Switzerland, Italy, Belgium, Denmark, Sweden, etc., etc. Its success has been so marked that there are upwards of 1 million apparatus in use in these countries, and its application is extending as its benefits become better known. The discovery of this process is a well-known French scientist, Mr. J. Christofleau, who devoted years of research to the development and application of his process, and the apparatus, which he finally perfected and patented throughout the world, is the result of his efforts. The apparatus referred to is illustrated above. The description. Terrestrial magnetism and telluric currents. The apparatus must be firmly placed on a post at least 20 feet from the ground, with the horizontal pointer pointing direct magnetic south and the perpendicular pointer to the sky. Number 1. Atmospheric electricity. The currents with which the atmosphere is impregnated are captured by means of a perpendicular pointer and the aerial wires of the apparatus, which serve as a conductor, by which means the positive atmospheric electricity is passed to the negative currents in the earth. The horizontal pointer, which is pointing direct south, captures the terrestrial magnetism and telluric currents which surround the apparatus. Number 2. The sun's action. Inside the casing of the apparatus are ridges, and outside are flanges corresponding with the thinnest parts of the casing. When the apparatus is placed in position on the post with the pointer direct south, the rising sun naturally strikes the eastern facet of the apparatus. The flanges on the outer portion of the casing serve to deflect the rays of the sun from the thin part of the casing to the thick ridges. These flanges, also being exposed to the wind, cool the portion of the casing to which they are attached. The resultant difference in temperatures cause an electric depot or store due to the metallic particles. The same action takes place later on in the afternoon on the third facet or western side of the apparatus. Thus, during the whole day, the sun creates an electric depot in the whole apparatus. Thermopile. Attached to the lower portion of the stem of the apparatus is a tube, which consists of two pieces of metal, one being copper and the other zinc, joined together by two solderings, and connected to the main stem, so that one of the solderings is exposed to the heat of the sun, while the other, being underneath, is shaded from its rays. This forms or generates an electric current from the copper to the zinc. That is, a negative and positive current, which is from there transmitted to that portion of the apparatus to which the zinc is attached. The whole becomes a thermal electric magazine, and is brought about by the action of the sun's rays and a contact of the zinc and the copper metals. The effect of cold and frost. Cold and frost both engender electricity due to the difference of temperatures transmitted to the walls or casing of the apparatus in the same manner as described in the preceding paragraph, under the heading of the sun's action. The effect of wind. The wind, when blowing through aerial wires, causes them to vibrate and capture the positive electricity with which the air is charged. And the effect of rain. On the top of the apparatus is a zinc saucer to which is riveted a copper plate. The very contact of these two metals alone is sufficient in itself to form an electric depot or store. And moreover, the saucer forms a receptacle for moisture caused either from the humidity of the atmosphere, the rain, the frost, or the dew. This action on the zinc and copper saucer converts it into a voltaic battery. The apparatus itself, being metallic and placed on a high post, is cold and naturally serves to draw the moisture from the atmosphere. All this electrical energy gathered by the apparatus is the positive electricity of the atmosphere, which is transmitted to the soil by means of the galvanized wire. The galvanized wire in the soil is directed in a straight line, direct magnetic north, for any distance required. This serves to capture the magnetic land currents. It is the combination of positive electricity from the atmosphere and the negative electricity from the earth which causes the continual flux and reflux of natural electricity in the soil. This current destroys all the insects and parasites which attack plant life by the very fact that the vibrations caused are proportionally greater than the vibrations of the insects themselves. Chemical formations are formed which will give to vegetation the fertilizing elements and nitrogenous products which are necessary to the nourishment and development of plant life. Now that's just 2 pages of the history of electroculture, and we can get into his notes on the next video, and so on and so forth. Thank you, everybody.